All right, everyone, this is Mr. Wyrick, and I'm here to guide you through the notes for Friday, February 25th. So the day after the ice, I will not be here. So hopefully this is enough to get you through the assignment, and you can hear my son running around in the background. So this is, and there it is, 3.2.12, proving a parallelogram is a rectangle. So on slide 2, it goes over the characteristics of parallelograms. Remember, the opposite sides, the top and bottom, left and right sides are parallel. The opposite sides, top and bottom, left and right, are also congruent. The diagonals, which would go to the non-consecutive vertices, so from A to C and from B to D, would bisect each other. They're not necessarily congruent on just the parallelograms, but they're always going to bisect each other. The opposite angles, A and C, B and D, will be congruent, and a single diagonal, either from A to C or from B to D, will create two congruent triangles. If we know it is a parallelogram, those opposite sides being congruent, we do a shared side through the middle. It makes side, side, side congruency. So on the next slide, slide number 3, it goes back over the characteristics of rectangles. So here's the thing about rectangles, they are parallelograms. So all the stuff that we just talked about for parallelograms also applies to rectangles. Okay. And then we have the following characteristics. The diagonals from A to C and from B to D are congruent to one another. So not only do they bisect each other, but they are congruent to one another, which also means, if you're paying close attention to the math there, each portion of that is equal, okay? So from A to the middle will be the same distance as B to the middle, C to the middle, or D to the middle. And all 4 of the angles of a rectangle are right angles. That's where the name rectangles comes from. So how are we going to prove that the parallelogram is a rectangle? Well, first off, we need to establish that we already have a parallelogram, okay? Prove the opposite sides are congruent, prove the opposite angles are congruent, prove that the opposite sides are parallel. You can check the 3.2.11 notes that we went over the other day to see if there's another thing you need to do to prove that those parallelograms are, prove that the quadrilateral is a parallelogram. So then you need to find one of the 2 things that's listed down at the bottom of this slide. You need to find a single right angle, because if one right angle exists in a parallelogram, all of the angles are right angles. And then you need to find out that the diagonals are congruent to each other. If you find either one of those, it is a rectangle. If you're doing some math associated with rectangles, it's probably going to be the stuff about the diagonals bisecting, and they'll give you some variable and say, how big is this if it's 3x plus 12 and it's down in the corner on the angle, so you just set that equal to 90. If you have any other questions, save them for Monday when I come back, and we'll see you then.